said that I was starting a boat design project, and so I have actually been working on it. This video starts out a few months ago when I was completing the drawings. I had to make some adjustments, make the boat displace a little bit more water because it was overweight. I added a sailing rig, just a basic drawing of one anyways, so that I could kind of see where things needed to ultimately go. And it was time to start breaking apart the model and building a prototype. So the prototype was originally designed just to be a kind of test bed, make sure that the boat performed as intended. And so I thought that would be a fun adventure to go on. So first I had to learn how to use my 3D printer. I decided to print in a wood-based PLA, if that means anything to any of you. And I really struggled getting decent prints. There were lots of failed prints, lots of garbage produced in the process. But once I figured out how to use the 3D printer, I started actually printing out a test piece and test parts for the sailboat design. So here we have figured out kind of more or less how to 3D print properly, and I am printing off the first piece of the hull. This is the middle section of the hull. I had to break the hull apart into pieces because it was simply too big to fit on my 3D printer for any reasonable scale. And so I figured out how to print the sections in pieces, and there were issues, but overall, it was giving a smooth surface. And that was the most important thing. I was having some issues with bed adhesion. It wasn't really sticking as well as I would have liked to the bed of the 3D printer. And you can see it caused a little bit of a problem on the bottom edge of all of the parts. Once I felt I had a really good handle on the 3D printer, I decided to print the most complicated part, which was the aft section of the hull. You can see I have this rather complex part that I was trying to print, and this should have been the entire back third of the hull. Unfortunately, the print actually failed, and it was a failure of the supports. Basically all the supports fell over, and so I couldn't continue on with the print. However, this part of the print is good enough that I decided just to use it the way it is, and then cut a new section, which is that part that's being printed right now. Anyways, I brought my clamps with me back from the storage unit earlier, and so I can start actually assembling this. It's not going to look pretty at first. I'm going to have to use some filler here, but this isn't just going to stay bare like it is. I have to say, I'm actually really impressed by the surface finish. It looks actually a lot like cardboard. This is mostly wood fiber. I think it's like half wood fiber, half PLA. And I chose this material partly because it actually has a fair amount of strength, and also because it's going to be a lot easier to work with. I bought just some standard super glue that I found at the grocery store, and I'm going to be using this to glue the parts of the boat together. The downside to using super glue is that it's not really 100% waterproof, but it is cheap and it's fast. It's strong enough to glue this part together. It's going to be at least as strong as the rest of the structure, and ultimately it's going to be covered with another material. Probably epoxy is kind of the way I'm leaning right now. And so that will provide the waterproofing and all that good stuff. None of this stuff is going to be 100% waterproof. That's just the nature of these materials. The plastic will absorb water, the wood obviously will absorb water, and it will fall apart if you leave it in water for too long. Well, I let this print overnight, and I think it actually turned out pretty well. I can still see I have bed adhesion issues. You can see on the corners how it curves in. It shouldn't be doing that. That's a bed adhesion problem. But for the most part, it actually stuck pretty well. Parts where it mattered underneath the waterline, those are all nice, sharp, and crisp. My supports all stayed intact, and I decided to try to integrate the rudder post into this print. It looks like it actually turned out just about right. I'll have to clean up the inside of it. It looks like it put a support in the middle, just the slicer software, just putting supports everywhere, which I actually kind of appreciate. And obviously it's a little bit hairy right now, so let me clean this up, break off all the supports, and let's see what we have. Well, I just finished taking off all of the supports. I drilled out the rudder post hole there, you can see all the way through, and I think it actually turned out really well, at least as well as can be expected with the minor bed adhesion problems. I'm gonna have to find some sort of solution to that. because otherwise things seem to be printing really well. And this rudder post is exactly how I wanted. It's a complex part. There's really no way you can make this one solid piece without a 3D printer. In reality, obviously I'm not 3D printing this boat, so it won't be made this way, but still pretty cool that that worked. Well, there's the hull fully assembled, glued together, and I know it kind of looks terrible. These joints are awful, but those are all going to be filled in anyway, so I'm not too worried about it. So I'm just waiting for the glue to dry a little bit. Unfortunately, I don't have 3 clamps, I only have 2. But once this dries, this boat will still be fairly fragile. It's being held together just in spots by the super glue, but that's okay because I'm going to be filling in all these holes, fairing it, and then probably adding a thin layer of fiberglass on the outside, which should help keep everything together. Remember, this is just a prototype. It's not for looks, although if it looks nice, that's good too, but this is just a prototype. So throughout this entire project, I've been having a lot of problems with bed adhesion. Just the parts don't really stick properly to the bed of my 3D printer, and I'm pretty sure it's the PLA I'm using. I printed with the regular PLA, but this wood-based stuff just doesn't stick very well to the surface. I have the settings dialed in as best I can, and it mostly works, but it's not good enough. So you can see I've had a bunch of failed prints like this one. Both times it was caused by the print lifting up off of the bed. Those 2 prints actually did stick well enough in most parts that when the part that lifted up got caught on the print head, the entire bed slid off. One time it actually launched it onto the floor. The other time it just shifted so the entire layer was over like an inch. And so obviously that wasn't acceptable. So I had to stop those prints. So I've been doing some research and seeing what I can do to fix the problem. There's a lot of potential solutions out there, but this is the one that a lot of people seem to recommend the most. It's just an Elmer's glue stick. Disappearing purple apparently is preferable because then when it stops being purple on the printer bed, then you know that it's dry. So you can see over here, the printer is warming up, and you can kind of see the haze that that glue stick left behind, so hopefully that does the job. Well, I just woke up. My 3D printer has been printing all night, and you can see perfect bed adhesion. This is definitely by far the best looking print I have done yet. Obviously a little bit of stringing here, but it's actually not too bad, and the surface quality is so much better than my other prints. Yeah, so most of my problems have been bed adhesion, and this solves it. The question is, can I get this off the bed now? Yeah, this is totally doable. I just need both hands. So I've finished the 3D printing part of this project. There's still going to be a couple other small pieces that I need, but this was the last piece, and it definitely looks like the best print that I've done so far. Seems like every print has been a little bit better than the last for the most part. In other news, I managed to break my 3D printed cabin here. Again, I already broke the other side, and this side just kind of snapped off as well. Just these parts are a little bit too thin, I think, and just doesn't have enough structural integrity. But anyways, this part here is the mock-up of the ballast. I'm thinking the ballast should probably be steel in this application, so I found some steel to turn into the ballast. And here it is. This is a steel bar that I found. I think it's actually stainless. But anyways, I found this chunk of steel bar that I'm going to be cutting into the steel ballast. It happened to be almost exactly the same thickness. It's slightly thicker, but it's not enough to make any sort of difference. I picked up this mini hacksaw to cut it at the hardware store. It was super cheap, and I figured it should work. However, this is steel and it is very hard. So actually cutting it has been a real challenge. You can see after about 10 minutes of work, I've managed to make a small dent in it. It should get a little bit easier once I get a little bit further down, but still, it's very, very slow going. Also, I found this cardboard box, which is going to be my dust containment and epoxy containment container. So any work that I do with epoxy is going to be inside that container, so it won't get anywhere else in my apartment. And it should help contain any dust that I produce as well when I eventually get to the sanding phase. Time to start epoxying the hull of my boat. So here is the boat. You can see there's big gaps from printer problems. As you can see, things got better as time went along, and there's fewer gaps. But anyways, those all need to be filled. It's not perfectly smooth between all the pieces, so we need to smooth that out with some epoxy and filler. and that will make the structurally sound. Basically, this entire thing is just being tacked together with super glue right now. It's not very solid and it would fall apart if I dropped it. So, gonna be very careful with that. If you're used to using epoxy, one thing you may know is that epoxy fumes themselves really aren't that good for you. So, what I decided to do is pick up this stuff. It says art resin on it. I don't know if there's any other art resins out there, but this one claims to be no VOC. So, it's also food safe. So, if I wanted to eat out of my boat, in theory I could. But more importantly, because this is a small space and the space I'm sleeping in, I really don't want VOCs in my apartment. So hopefully this stuff will do the job. So that stuff is going to be great for coating the hull and everything by itself, but to make the filler, I'm actually going to be using wood flour, and I've done this many times on real boats. You can also make your own if you happen to have a lot of sawdust hanging around or something like that. I don't have any way of producing sawdust myself. So the wood flour is going to do it. I'm going to use a very, very thick mixture, so it's going to be mostly wood flour and just a little bit of epoxy. And hopefully that should make a nice sandable surface. Okay, so there it is, all epoxied together. All the holes are filled, I think. And I did spill a little bit of wood flour on top of the boat, which is why it has all those speckles there. But as you can see, everything has stayed within the contamination area of the cardboard box, and I didn't actually use very much epoxy for this particular project, so I am hoping there won't be any on my desk later. Meanwhile, my hacksaw has been making a dent in this steel bar. Really not the right tool for the job. Hopefully I can get through it. I don't really have any other options, so it is what it is. All right, so we finally made it to the sanding stage of the boat. I bought some sandpaper. For some reason, the sandpaper is extremely expensive right now. I'm sure if I ordered it off Amazon, it would be a little bit cheaper, but in the small quantities I need, I just went to the local hardware store and it was costing something like $2 a sheet. The cheapest stuff was like 99 cents, but cheap sandpaper doesn't hold up more than like one brush past anything. So I don't do super cheap sandpaper, but even just the low acceptable quality stuff is really expensive. Next time I'll have to order it off Amazon. I'm pretty sure I can get it for a lot cheaper there. So anyways, let's get started with the sanding. Okay, so here we have the boat model. It's sanded down pretty well. You can see it's not completely perfect, but it's pretty close. It's about as good as I'm going to be able to get with the tools that I have available to me and the space I have available. And I'm not really doing much with the interior. I'm sanding the cockpit area just a little bit, but that's about it. Remember, this is just kind of like a development prototype, so it doesn't need to be perfect. It just needs to work. Okay, so this is now sanded down all the way. I went all the way to about 220 grit. Might actually be a little too much for the epoxy. I'll have to look at the label and see what they recommend. But the epoxy I'm using is self-leveling, so it shouldn't be too bad, not like regular epoxy, which just kind of runs everywhere. All right, so I have drilled and tapped the holes, inserted the threaded rod into the holes. I'm using a little bit of super glue as basically Loctite, and is ready to be installed on the hull. So we'll see how this goes. And there it is installed. You can see there's a bit of a gap there. I did cut it slightly short, and the holes aren't quite drilled in the perfect location, so it is kind of pushed a little bit towards the front. You can see it's not 100% straight, but it's good enough. All right, so I filled up the sink with a little bit of water. Should be deep enough to float that. There's no major holes in it. I suspect it'll leak because I have this bit of a gap here, and is kind of an open hole going into the hull. But it should float at least for a little bit. So I just wanted to make sure that we're in the ballpark at least for weight and balance. Yay, it floats. It looks like it's floating right on the water line that I designed. So in some ways that's a good thing, in some ways that means it's probably overweight, but given the construction, I'm not really that surprised that it's overweight. But the most important thing is the ballast is in the right place. That was the part that I wasn't 100% sure about. So you can see the hull is slowly sinking, and that's because there are holes in the bottom of the boat still. So what I'm gonna do is take this out of the sink, let it dry out a little bit, and then start mixing up some epoxy and get the whole bottom sealed up. Well, since the last clip, I've actually taken a pretty long break from this project. I stopped working on the boat for maybe about a month. I had other priorities, and getting myself buried in epoxy just didn't sound like a lot of fun. So anyways, I actually did end up getting back to the project, getting the boat sorted out, and let me show you what I did. The first thing you may notice is this enclosure. My 3D printer is actually inside, it's on the floor now, and that's because I decided to change filaments after my experience working with that wood PLA. There were a lot of problems with it. I actually broke part of the keel, and you can tell that the layer adhesion, 3D printers print in layers, and they don't always stick together as well as you might like. So I decided to change to a different material that would probably be a lot better. So I started using ASA, which is a different type of plastic. You can see I printed my rudder in it. So here is the rudder. It's all sanded down so it's perfectly smooth, but even before then it looked a lot better than anything I printed with the wood PLA. Here is the tiller handle to control the rudder, and again, it looks so much better than anything that the wood PLA could have produced. The other thing that I did is I found this little piece of metal, so I cut my rudder post. I cut a bunch of notches in that rudder stock there, and then basically just cast epoxy around it into that little hole. And so hopefully that holds up well. It feels strong enough. I'm not going out into the open ocean with this. My life doesn't depend on it. I wouldn't build a real rudder this way, but I wouldn't build a real rudder this way anyways. But anyways, this actually was printed. I sanded it down, epoxied it, sanded it down again, and it is very smooth, very good look. The seat here, you can see I did the same thing with. It's epoxied, it's sanded down. The bottom side here, I didn't really bother finishing it too well because no one's ever going to see that. And that's what it looks like before sanding and everything. I did sand it a little bit just in case I decide to put some paint on it. I don't know if I will. And then over here, we have the hull, which I epoxied, I sanded. I used a lot of filler around the ballast here and faired it all in. It's not perfect, but it's still pretty good. And you can see the other side, it's still fairly similar. The foredeck here, much smoother. You can see little lighter patches where I have either just sanded all the way through the epoxy or just made a little thin spot. And so I've probably overdone what I really need to do sanding, but I'm just trying to get it to look at least decent. And then of course over here is the interior, which I sanded it down, probably not as much as I should to get it looking really good, but you know, it's good enough for now. The cabin over there, I broke it for about the 5th time, and so now it's just kind of waiting for the super glue to dry to glue the pieces back together again. There really isn't a lot I can do. I could probably reinforce it with some structural pieces on the inside, but these parts here, it's just a poor design, and it's totally my fault because I designed it, but you know, it has a nice hard corner there, and so it just breaks right at the corner anytime you put any stress on that part at all. But anyways, next step is going to be painting, and so I bought some spray paint. It's going to be gloss white on top, and then for the rest of it, it's going to be this matte red color for kind of some simulation bottom paint, but really cheap paint that I found at the local store. Since I don't have any outdoor space here that I can work with, I have been modifying my cardboard box. So you can see I've cut the flaps on the side in half. I've kind of taped them down. I've made this nice enclosure here. This is all going to get cleaned out. I just finished sanding today, so there's still a lot of dust in there. But I installed a exhaust fan, and my window is right there, and it opens up. I found this fan for dirt cheap. Apparently greenhouse supplies are really inexpensive, so that's where this comes from. This is actually a greenhouse supply, and it just goes into a 4-inch duct, which happens to be the same as a dryer duct. So I bought this flexible dryer vent. Those things, again, cost practically nothing. And so eventually when I'm getting ready to paint, this is going to be pointed outside, and I can just fire this up, and it should exhaust any fumes that I produce. The only thing I'm a little bit concerned about is my spray paint may be a little bit too close, or a little bit closer than I'd like to the work that I'm doing, so I'm going to have to kind of manage that, probably try to move the spray paint container a little bit faster while I'm painting to get a good finish, or at least a decent finish, and that's kind of my hope. But anyways, the project is basically stalled out again, and that's because it's 16 degrees outside right now. Not quite to the record low for the area, but we're pretty close. We're kind of in the ballpark. We're getting daytime temperatures in the low 20s, and that means that if I open my giant window, it's going to get really cold in here, and so both my paint won't dry and it's going to be really cold in here. It should be warming up next week, but until then, the project is just kind of in a holding pattern waiting for the weather.